So in continuation of the previous video, we are looking for a complex structure, and then we will run a minimize energy run in the Chem 3D. So you will see I will make a bigger structure, and then you will understand that how much time it would take. So I am making a structure over here which is bigger in size. Okay, so we are making a bigger structure. We are taking stereochemistry also in the account, and then after we will see whether these structures are okay or these structures are not okay or whatever. So we are doing this and that. So once you have it, we are having this, that, so many things we can add. Just to make it complex, I am making all these changes. So as per your requirement, you may do it. I am doing it just for the sake of explanation, students. So you see here, we are having so many bonds, this, that, whatever, this, that and all. So the structure is here, and a few more things also I am going to add here, so that it will be easier for you to judge whether this is okay or this is not okay. A few bonds also, for single bond I am adding. So here I have been taken single bond to add more, and then after a few more structures you may add it. Now after doing this, first we have to see whether there is a red signal or not. No, there is no red signal on the screen. That means there is very much possibility that our structure is correct. So just to check the structure, first you have to select it through lasso. Once first we have done it, structure, and then check structure. You see there is no error found. Our structure is perfectly correct. Okay, and then after to this structure we have to clean up. So here it is clean up structure. The structure is almost clean. Now what you have to do? You have to copy the structure. We are copying this structure, and then we have to go to the 3D Chem office. So for going 3D Chem office, we already have this 3D Chem office in our this particular system, and then after we will go to that, and then we will see. Just now we were doing it, and then there were so many things. So you see, once we are here Windows, Edge, Word, Excel, PowerPoint, whatever, and you would see there are so many other things also are there. And then first we are clicking all of the programs. So you see Avogadro is also here. All these things you also have. BioVia, Discovery, Studio Visualizer, it is also here. Likewise you have to see Chem Office 2016. There are so many versions. You see Chem 3D 16.0, plugin and ActiveBase, README, Chem Draw plugin, Chem Draw Professional 16, Chem Finder for Office, Chem Script Demo. You see, Chem Office is a complete software from Perkin Elmer, and it is a very nice software for your computational chemistry. Now we are going to our Chem 3D, and I told you that every time what you should do, enable hardware, acceleration, and okay. Once you are doing it, now you have to copy it. Here we have to paste it. Is it clear? Now here you see in the right hand side there is a structure. So now what we have to do? We have to go for calculations, MM2, and then minimize energy. So you have to run it, and you have to, after putting it run, you have to see here the screen output. Here it is showing calculation end. So first I am doing run the program, and then after we will look at it. Run. You see there are changes. You may observe here there is calculation on the left hand side, and here you may feel that how the structure is been changing. There are changes. The bonds are rotating just to get the minimized energy in the 3D version. So it is been done. Continuously the calculation is moving. Meanwhile the structure is also getting moving, so that you can get the best result out of it. Calculation end. Now you see that means our structure is being got the minimized energy. Once you have the energy run, minimize energy run, now file, save as. Now it is your choice that how do you want to save it. .pdb, smiles, this, that, whatever version, .png, .mol file for Avogadro, whatever you want to save. This time I am saving it as .pdb, protein data bank file. Here whatever name you want to give, you may give it. This time I am giving it just one name, nothing. Then save. So they are going to ask you where you are going to save this particular. So on the desktop I am saving just for the explanation purpose, and it is being saved. Go to the desktop and just find out whether we have this structure or not. So refreshing, yes, we have here. You see, we have here our structure. So this .pdb structure you have to open with some software. So here we have BioVia Discovery Studio, which I have been clicked. So through this the structure is going to be opened, and you may use this .pdb structure as a ligand for further calculation, for further processing in computational chemistry, for molecular docking, molecular dynamics simulations and all. First time when you open this software, BioVia Discovery Studio, it takes a little bit time. For first time means when you are just doing the operation starting. Once you are doing it for 1 hour, 2 hour continuously, it will be opening very soon, because it has to collect all the data which is already fed in this software, like algorithms, this, that, whatever. Once you open it, it just the software recalls all these algorithm, all these data, and then it comes and then it appears. Is it clear? That's how you do it. Once this software is getting opened, we are doing some another job on the Chem Draw. So I am going there in the Chem Draw. So you see here we are Chem Draw. You see structure preparation you have known. Now in the structure when you go, you see here there is operation, convert name to the structures, convert structure to the name. So if you want to give IUPAC name for this particular structure which we have just randomly designed, then also it is possible through this particular software, because algorithms are there in the software, already calculated algorithms, the mathematical formulas are being fed here. So what we are doing, we are changing structure to name. So you see here it is an IUPAC name for this particular very complex structure which you designed just randomly. We were not thinking about anything, and we just randomly did it, and you got this particular name for the structure, and it is IUPAC name. That's how you may do it. So many things you may do. You see, once you want to explore more and more about the whatever things I have explained you already in the class, so many things were related with the Chem Draw software which we have already learned, but a few more things I am explaining you here. You see, once you go to the edit button, I have explained you mostly all the tabs, but to know more and more about the structure, it is about doing more and more practice and learning by doing. So once you will click up all the tabs one by one and explore what is there inside. There is no harm in it. Once you will explore more, you will read and you will understand more about the Chem Draw software. So you see here, typing, copy, paste, clear, select, all small tabs are here. Get 3D model, insert file. Here you see copy, paste, special, 3D model, insert file, insert object. All these small things are there in the edit tab. Then you see in the view table, here on the main screen we are having only essential tabs. But there are so many things which you may observe through this Chem Draw software. So you see here we have in the view tab, biopolymer toolbar, BioDraw, show general toolbar, style, object, structure, Chem Biofinder, analysis window, chemical properties window, periodic table, character, toolbar, so many things. Why? Because for this structure, whatever data, so suppose I am clicking this analysis window. So you look now in this analysis window, the formula for the structure which you have been designed randomly is been appeared. Exact mass of the structure you need not to calculate, automatically calculated mass till 4 decimals. Here you may change the decimals also. If you want to take till 2 decimal only, possible. you want to take till 6 decimal, possible. Likewise, so till 5 decimal only, this is showing you the limit. It might be possible for some other structure when the exact mass is small. Suppose here only 2 digits, it will show you till 6 decimals also. So till 5 decimal it is showing us, because this is a significant number for this particular Chem Draw. So you see here molecular weight is there, m by z. That means when you do HRMS, GCMS, whatever you go for, so then you use these mass. Elemental analysis, carbon and hydrogen, only 2 things are there in this particular structure. So carbon 89.10 and hydrogen 10.90. This kind of analysis window you may open and you may know about the particular structure. Understood? So now our Discovery Studio file is ready. So you see here the structure which we have designed and we change it into .pdb. It is being shown in the here. Now you may make any changes to this particular structure. You see here it is possible. This is Discovery Studio Visualizer, in which you may make changes to the ligand, and after changing this ligand you may use it as a docking particular. In docking you have 2 things. One is your protein, and to get the protein connected you need a molecule which can be serve as a lead molecule for your further research. So this ligand, if you have been synthesized or you have been designed it, then you may check it whether it may serve as a lead candidate, drug candidate or not through docking, and you may go further for your drug design and computational chemistry. That's how, if you want to save in this, it may possible save as and all, whatever you may do, but you need some particular file like .pdb and all to visualize it in Discovery Studio Visualizer. Which how we prepared? First of all, we have been created a 2D file in the Chem Draw 2D, and then after we check the structure whether it is corrected or not. Once the accuracy of the structure is being calculated or being assigned, then only we just copied it into the 3D model. We were going for a minimize energy run. After minimizing the energy, we saved it as .pdb, and after saving it as .pdb, we are visualizing it now into a Discovery Studio Visualizer. That's how you create a ligand to do further molecular docking and molecular dynamics simulation. So today's video is till here only. Further things we will understand in the class also and through further videos. Thank you, students.